Hi there, welcome back to CTO Connection. For those of you who don't know me, my name's Peter Bale, founder and CTO at CTO Connection. We're an invite-only community where senior engineering leaders can share problems and get answers. Thanks for joining me for our summit today, where we're focused on moving towards continuous application security. Historically, application security was the thing that one overworked security engineer did sometime after launch, when they got to it. Or even worse, it was a blocking function for maybe quarterly new feature releases, which needed security testing on staging before they could be launched in production. But that clearly makes no sense in a world where most teams are now shipping to production multiple times a day or a week. So the question then is, how can we start to shift security left in the same way we did with ops in creating the DevOps movement back in the day? Today, we have two amazing speakers sharing their experience on this topic. First, we've got Scott Gerlach. Scott is co-founder and CCO at StackHawk and formerly the CISO at Twilio SendGrid, and he'll be providing some thoughts on making sense of application security for CTOs, a great kind of grounder to make sure we've got a shared understanding to move further around this journey. And then we've got Simon Maple, field CTO at Snyk, who'll be sharing his thoughts on how to create a great developer experience for AppSec. We then have an AMA where you can share your specific questions about how best to implement or improve your application security program. Also, unlike many of our events, today's event would just be an hour, so hopefully you found it a little easier to slot it onto your calendar. Let's kick off with Scott. Scott?
We do a really good job in security of making up stuff, making new terms, making new things, and then expecting everyone to just be like, yeah, I get it. And there's a ton of terminology out there, but I always like to think about engineering and software development and the security team's role in that, whether you have one or not, kind of like a race team, right? Like someone who's trying to put a product on a track to entertain and win. And I like to think of that security team as kind of the safety team. Now, early racing, there was no safety team, right? So things went bad. Problems happen. So that's where that security team comes in. You don't have to have one to care about this stuff that you're producing and manufacturing and putting on the racetrack. But it helps, right? Because they're experts in safety. Software composition analysis also has a new term recently of supply chain, software supply chain. I like to think about, some people think about supply chain as like, here's the whole thing. If I think about it in a manufacturing kind of like race car manufacturing terms and process, I think of it as like the raw materials I'm pulling in to build my race car, whether that's, cheater engines from Honda. It's F1 kickoff. So we're going to throw some F1 stuff in here, or raw aluminum for tubing or raw carbon fiber, whatever that is, right? You want to check that one that comes in. That's not the safety team that's doing that. That's the engineering team, the team that's building the race car. They're checking tolerances and specs on that raw material as it comes in, so they have confidence in it when they build the race car. So SAST, static software analysis, and DAST, dynamic software analysis, is kind of like, let's put it back in race car terms. SAST is like looking at those raw parts and putting them together and going, these fit. And when they don't fit, it goes, this part right here doesn't fit. That's great, but that doesn't help you test. And by the way, this is very analogous to software linting, right? So linting and static software analysis tools are the same kind of thing. One, they're looking for two different things, but they do the kind of the same function. One goes, hey, did I write this the right way? Is it formatted pretty so it's maintainable, people can read it? The other one goes, hey, this actually has a problem in it in how the flow is happening through that software. DAST, on the other hand, is like integration tests. It's like the running race car, making sure it rolls around and drives and the engine starts and there's no problems with that as it's working, right? So if we start the race car, we put the race car in the wind tunnel and we start putting wind across the tunnel, we've designed the race car so that it steers and turns and the accelerator works and the brakes work. And then we start putting the wind across it and the whole race car goes flying away. Well, that's not what we designed it to do. So our integration test didn't test for that. This is the opposite of this. What bad things can happen to my race car? And when I put wind on it, oops, somebody put the wing upside down and now it's flying around. That's bad. But we wouldn't have figured that out if we didn't do that kind of running analysis of our application. Yeah, there's obviously more stuff you can do, right? There's more things you can do at runtime. But if you have a really good grasp on those three things around your application itself, you're in really good position. The next parts you got to think about are the racetrack itself, the surface of the racetrack. So your container or your infrastructure security, go walk it around, see if there's any giant potholes that are going to break everybody out. So making sure your container is built without remote code execution problems or whatever that is. And then doing infrastructure security as well to make sure you've got sane configurations on S3 or Google Cloud or Azure settings. And the really fun part here is, right, your racetrack can be perfect. You could deploy easily, because they're default this way, secure infrastructure on Amazon, Google Cloud, Azure, DigitalOcean, whatever that is. You could absolutely deploy that secure because it comes default out of that. That leaves the next part, the race car, right? The application, the thing that's supposed to be handling the data, showing off for your customers, intentionally supposed to be handling the data. That's the last bastion. So it has obviously intentional access to the data you're trying to protect. If someone wants to get at the data, they're definitely going to try to go through the application or interrupt your race car so it can't run. So penetration testing is really valuable. Automated offerings, I think you can start moving some of that stuff into the development pipeline. You can start doing some of that. I like to think of it as negative validation testing, right? So we write a lot of unit tests and integration tests and functional tests that do positive happy path testing. You can think of that automated pen test or DAST or SAST or whatever that is as part of that. And that's kind of negative testing. Does my application respond correctly when bad things are thrown at it? So that's what I think that's really good for. I don't have a great analogy for pen testing and racing. However, what you want your pen testing program to do is find really hard to find things. So, when you design, let's see, I'm going to work on this analogy right now. When you design the racetrack and you set up the race rules and you put the race cars on the racetrack and someone goes, hey, you know what? It is not in the rules. It doesn't say I can't cut across the middle of the track and just make my loop short, right? That's what pen testing is really good for. Like, hey, I found a loophole in the rules here, and now I'm running half laps and everyone's running full laps. I'm definitely going to win. But that's the analogous to pen testing, I think. Where you want those people that are kind of thinking outside the box, testing the application, finding some of that really hard to find, because it's just logic stuff. It's logic problems, right? You want them working on that to find those kinds of things. And the way that you can do that is take away all that low-hanging fruit by doing some of that other testing earlier. So taking away the low-hanging fruit of, I ran a DAS scan and here's 100 issues that you never knew about. I knew about all of those. Find something hard to find. And that's where you can get a lot of value out of the pen test, is really making pen testers exercise their brain and find really hard to find and valuable to you things. I think bug bounty programs are interesting. If you have a really good baseline of where your application is and you understand the security problems of it, it's probably very valuable. One of the challenges I've always found with bug bounty programs is it's kind of an unlimited budget number, right? So as a CISO going to the CFO and going, hey, we want to do a bug bounty. And he goes, cool, what's the budget for that? And then you say, unlimited. That doesn't really go very well very often. But if you can say, hey, I don't know what we're actually going to pay out, but I can guarantee you we're not going to get nickeled and dimed to death. When we do get a bug bounty report in, it's going to be very, very valuable and probably worth paying out, right? So we could have spent $150,000, $250,000 a year employing a pen tester, or $30,000 to a bug bounty person if they find a really bad problem with our site that could affect users, right? So it's kind of a mixed bag, Peter, of do I know where I am so I can kind of make an educated guess on what I'm paying out in bounty, or if I don't know where I am, I have no confidence in what this is going to cost me, and I'm going to spend a lot of time working through a lot of little issues. It's going to feel like you kind of get nickeled and dimed. Here's the security person problem, right? We do this thing where we're like, hey, we're going to teach everyone about application security. No one that's a dev or a CTO, or they don't want to learn that stuff to the depth that an application security person wants to learn it, because it's not their job. I think the things to do to keep up with what's going on here is get good tooling that gets you good information early, so you can make decisions about what's happening there. And the decision is the important part, because right now, most people are making passive decisions. I think it's probably good. It's probably in good shape. Let's deploy and see what happens. Whereas you can start making active decisions. And you know what? It doesn't really matter if they're the wrong decisions. It's that you're now making active decisions. Hey, we should hold this deploy because we have this bug that we should fix. Hey, we have to deliver this code because it's contractually obligated, but we can fast follow and fix that bug. Those are now active decisions, and I think that's more important than keeping up with application security trends and nuance, and having those tools help you in that process and in that culture of making those active decisions, and just kind of instead of the passive decision. In a dev org, I would hire an application security person first. If I had to hire a specific person, I would hire someone into my engineering org that sat with all of my Scrum teams, like one at a time, right? Not everybody all at once. Big bang explosions don't work in software engineering. Hire that application security professional that sits with software engineers and tries to help them solve their problems, instead of trying to hire some external team or group that's managing all the risk around the entire organization and trying to do everything all at once, making people mad. Hire that one very collaborative person first, probably. That I think that's actually what I'm going to end up doing in my org, is hiring someone that works with engineering first. Because again, that's probably the most important thing that I'm producing as a race team, is my race car. I think the very first thing you got to ask is, how do you think about absolutes? Like, if we have a list of vulnerabilities, which one should we fix? And if the answer is all of them, wrong person. Like, that's the wrong person. Like, you don't do that with software development, right? You don't go, what features should we build? All of them. You go, this one, because it's strategic for us, and we can get customers, and we can build things to attract people to the race, and then we can build more features. Again, the pragmatic version of an application security person that understands what they're protecting, why they're protecting it, and how it helps the business is just as important as they're skilled at what they do, right? Being able to communicate what and why is just as important as where and when. I think this is probably one of the toughest things, right? Because in isolation, all these tools we talked about will go, this is the most important thing you have, right? And then it's like, okay, everything's important. When you can get these tools to start working together and going, hey, I found this, and also I found this, and also I found this, I would start working on those kinds of things first, right? If your software composition analysis says, hey, you got to upgrade this library, and your static code analysis says, yeah, well, you're also using a function wrong to get to the library, and then your dynamic code analysis goes, and also this is discoverable and exploitable from externally, that's where I'd start. So being able to use those tools together is really powerful when you can get it done right. Outside of that, I always think in software composition analysis land, if you can upgrade a package, you've got good unit tests and test functionality in your integration environment, and you can upgrade a package and something goes, hey, you're a minor rev behind or a major rev behind, and you can just bump a version and keep it up to date. Take all the wins you can. A lot of that stuff does automatic PRs for you. So if tests are passing, upgrade that stuff, because it's not going to always happen that way. And you don't want a huge list of Which ones of these should I have to go work through? I think it can be daunting for a CTO to understand and start on their application security cares list. So it can be daunting, and there's a ton of messaging out there and tools out there. But pick a tool, pick one tool, figure out what's going on with it, figure it out with a team, what works in your organization, what works in how you develop software, iterate and expand from there. So that one tool could be SAST or DAST or SCA. Depends on what you're developing and where you're putting it, those kinds of things, and what you're looking for. Just start. I mean, there are great tools out there that we can talk about. I think Simon's going to talk about some of this a little bit later, but there's great tools out there that can really engage your dev team to be able to make those decisions as you're developing software.
Thanks so much, Scott. I do want to take a moment to thank one of our two partners today, StackHawk. For anyone who doesn't know what they do, here's a video that explains their offering.
Software development has changed, with code being pushed to production faster than ever before. But what about application security? Today's engineering teams need an application security tool that keeps up with the pace of modern development, leaving manual or scheduled tests after deployment in the past. Instead, developers need a tool built to run within their existing workflows to find and fix security vulnerabilities before production. Introducing StackHawk, the first of its kind in automated dynamic application security testing, allowing software engineers to find, triage, and fix vulnerabilities within existing workflows. StackHawk's Docker-based DAST scanner is simple to run and built for modern applications and APIs written in any language. With lightning-fast security scans, it tests all paths and API routes for vulnerabilities, returning results for review and triage in minutes, all automated within your existing delivery pipeline. See the request and response payloads with evidence of the security bug. Recreate the bug with a simple curl command generator so your team can easily step through code and fix mishandled requests. After that, it is up to you. Fix it now or fix it later by adding it to your existing backlog, or accept the risk, silencing the finding on future scans. Built on the open source Zap project, the industry standard in dynamic application security testing, StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. StackHawk, automated application security testing for modern engineering teams. Get started for free today at stackhawk.com.
Okay, next up is Simon Maple, Field CTO at Snyk, who's sharing some advice on how to engage your dev team with DevSecOps. Simon?
Traditionally, security testing was very much a point-in-time thing, and that was similar to many other phases in the waterfall process. The DevOps way of developing software really speeds this up, and it puts a demand on security that it's done rather than a periodic once every 6 months, 12 months kind of thing. It makes sure that you do security at the pace at which you want to deliver code and not the other way around. So that's core. Now, if you think about the number of security folks to developers in a typical organization, you're looking at around maybe one security professional to maybe 100 devs. That kind of ratio, your mileage may vary. So how does that work? It can't scale. It bottlenecks on the security professional when you try and deliver a large number of changes over a short period of time. So security needs to scale with developers. It needs developers to own and be responsible for the security of the code and the applications that they deliver. Now, in order to do this, you need very effective processes in terms of the secure development. You don't need developers to be experts in security overnight. And that's one of the things that Scott mentioned. Devs don't want to learn security. They care about secure coding. So you want to add security into that process in a secure development way, whereby they remain independent teams and are empowered by the organization, specifically the security teams. Historically, devs don't like security. Security are the department of no. They're the teams that bring bad news. They bring you problems, not solutions. They're not dev friendly. This is the old way of our software delivery, traditional security mindset. Go to a developer, any developer, and say, do you want your code to be secure? Do they want their code to be of good quality, pass tests, unit tests, integration tests, etc.? Everyone will say, yes, of course they do. Developers have a natural pride in the code they deliver, the applications that they deploy. However, the industry has needed to shift. Because of these new DevOps movements, our requirements to deliver faster, deliver in smaller pieces of code changes, we have needed to change. When your security processes and your practices are not dev friendly, I don't blame developers for not wanting to own security. And when organizations and groups and businesses are successful in adopting those modern secure development practices that are supported and empowered by the security team, that's when you'll see a shift in ownership and willingness, in the same way that your developers have that willingness, ownership in providing high quality code, in owning the tests, writing the tests, and running the tests. It just becomes a part of the development process. One of the core ways of making sure that you're doing things right, you're doing things well, is really through measurements and being able to look at how you are moving the needle, how what you are doing is making things better or making things worse. A great way that companies are achieving this is through scorecards. And scorecards isn't necessarily a security only thing, but it's a great way of being able to show each team how their practices, some of their operational data, number of vulnerabilities, for example, number of vulnerabilities fixed, their risk assessment, how that is changing from month to month, from week to week. It's very, very important that this is done in a very visible way, in a very transparent way. And it sometimes gets developers to almost gamify the process to say, hey, I don't want to be that worst team. I want to make sure that what I am doing is having an impact, making our team more successful. But it goes beyond that. We need to make sure that the scorecards go to the right people. Does the management care? Does the VP of engineering care that this scorecard is getting worse or getting better? Does the owner of the business unit care? That accountability, if it doesn't come from the top, it won't flow down. And as a result, if your organization doesn't hold themselves accountable, what chance does a developer have of holding themselves accountable? Without this, it's very, very hard. It's not impossible, but it's very hard for that development team to make sure they spend the right time on ensuring that they are doing the right things and making sure that they are doing things securely. So think people, process, tools. This is very similar to the core DevSecOps pillars, this mantra that we want to look at. So why don't we start with people? And I think this is important, that I'm not just saying we're going to start with people on this question. In your organizations, start with people. When we think about that top-down prioritization that I mentioned in the business, make sure it's important to them. If it's not important to your CEO, to your senior VP or CTO, why should it be important to developers? Collaboration is one of the most important things. And with DevOps, we care about breaking down silos. The collaboration between the development team and the security team is at the very core of DevSecOps. From a security point of view, we need to think about the empathy that each security engineer or security researcher, etc., has for the development teams. Think about what the maturity of their team is like, not just in the way they look at security, but in the way, in general, they look at tech. Are they adopting some of the new techs? If they're not adopting some of the new techs and not moving at speed on their own development work, why are you expecting them to do that in security work, for example? So this collaboration and empathy, it goes both ways, but the development team tend to push back or back away from the security team very often when you're talking at different odds. It's very, very important to have clear, common goals that you are all working to. If you don't have that, you're not collaborating. One person is trying to get someone else to do something on their behalf. A great way of doing this, enforcing and growing this collaboration is through security champions programs. They're a great way of putting that formal process around the engagement between teams. Now, Scott mentioned previously, make sure security sit with developers to help them fix their problems. And the security champions programs is a great way in which you can get security champions from development organizations and people in the security team to sit down and talk about what the problems are and help fix those problems. And last of all, I will say reward and recognize things that have been done well. When individuals do things well from a security point of view, they need to be recognized, even if it's a call out from a VP in a department meeting. Also, recognize when teams have achieved something and try to work out how other teams can replicate that through this golden path, golden stack, this paved road of how one team can follow other teams with that. So start with people. A security champions program is a formal program that it allows developers and security teams to collaborate. The security champions will typically cover the entire organization by having one security champion per team across that development organization. What that allows is the security team to all of a sudden have visibility into the whole development organization. And those security champions can create scorecards and provide data back to the security team to say where they're doing well, where they're not doing well. And it's also a great way to plan and allow the development team to decide what are the things that are their biggest pains and what are the things that they want to fix in the coming quarters and halves of the year. Simply don't tell devs what to do. You want to work with the developers to identify what is the best way of getting a particular thing done. And one of the cool ways of really coming around this is to have shared goals. So it's not a security goal that the security team are trying to meet by making sure the development team is doing something a certain way. It's a shared goal which the development team and the security team are trying to meet. The security team and the development team need to create the process, and that can only be done via that discussion. The security team can talk about the risk and some of the ways of doing it from a security point of view where it makes most sense. The development team care about the changes in process that will be adopted by the developers in the right way. Now, when we think about the right way, you want to make the right path also the easy path. When developers have two options, there's the easy path, and there's also this right path that we want you to take. It's very easy for a developer to say, you know what, I haven't got time right now, or there's these other things I need to do. I'm going to pick the easy path and choose workarounds away from that. So how do you make the right path the easy path? Well, in terms of adding process, automation is key. Making sure that automation not just happens so that every pipeline has security testing and that validation happening all the time. It's happening at the right time that the developers want. If a developer wants that automation in a Git repo versus a CI process, that's what you should do. Equally, think about it from the terms of solutions, not problems. The traditional security method was to give developers problems. What we want to do here is have processes that provide your developers with solutions. There are typically fewer solutions than there are problems because one solution can very often fix many vulnerabilities or many other security issues. Other things like making sure documentation of your processes, your tools, how teams and who the right people to go to helps you make developers make the right choice of choosing the easy path. And of course, any process changes, the education and that raising of awareness of what the right process is and why is core to creating these process changes and making them well adopted and understood by your development organization. Tooling is one of the crucial areas, as is process and people. You can take a horse to water with other methods, but they need to want to drink themselves. Now, good tooling for developers is tooling that is dev friendly, tooling that provides a good developer experience. It should be a pleasure for developers to use this. So what are we talking about? Let's break down dev friendly or dev first tooling. It should be self-serve. Developers should be able to go get tooling, learn about how to use it themselves, grab it, and get started very, very quickly. There should be tight integrations where they want, not where the tool wants, where they want in their specific stack. In case sometimes there's not, or in case a developer wants to do something differently, well, that happens all the time. There should be strong API support. There should be strong CLI support so that you can build on top of those tools, so you can get the data from those tools and use them in the way that you want to consume it. IDE support, the idea of getting that information back early, getting that feedback, as Scott mentioned, which is so important. IDEs are the place where devs want to code. They don't want to go out to a vendor's website to get the information about how security tests run. Let's push that into the IDE where developers want to live. Another really strong way of telling a tool is a strong developer tool is having a very solid community behind that. Is there a good open source adoption? Is there huge numbers of developers that are adopting this tool? It's a great example of how tools get that natural adoption. And of course, there are so many different areas of security testing in our code, not just, SAST and SCA and DAST. Just like Scott was mentioning, we need a platform of tools that work together, and not just work together, but enrich each other. The idea of combining data to get a more accurate assessment of what to prioritize, how we can reduce false positives, because we want to build trust. We want to build that relationship between the developers and the tools so that when they get the results back, they trust it and they act upon that. But one of the core things is tools can easily, particularly in security, overwhelm developers by giving them huge numbers, hundreds of thousands of vulnerabilities. It's easy to roll out with developer tooling a tool that allows you to consume that data at the speed that the teams want to do that rather than the tool. So initially start it as visibility, then slowly dial it up as fast as the teams are willing to accept that. And that needs to be decided by the teams, not the tools. So that customization will allow developers to act on what they want to act on. It should help them and empower them in performing the security tasks rather than hinder them or cause a bottleneck. And that's what makes a developer tool so important in this space and what makes good tooling good. The last thing you want to do is overwhelm your development team, as I mentioned. The core thing to do is introduce things at the speed that they are willing to consume. So to start off, when you introduce a new process or if you introduce a new tool, the core thing to do is not change their workflow significantly. So let's try and do things for visibility only. Let's take a vulnerability management tool. The last thing you want to do is provide huge numbers of vulnerabilities, block builds, give developers extra steps that they didn't need to take prior to the introduction to that tool. So what you want to do first of all is introduce it in a way whereby there is visibility, perhaps for the security team to be able to assess the risk over their organization, but also to the development team so they can see the new process there, the new information which is being made available. They don't necessarily need to do anything about it, but they start becoming familiar with it. The next step is to say, okay, we want to now become better. One of the core things that you want to avoid, as I mentioned, is overwhelming. And when you introduce a new tool or a new process to an existing project, it can be very easy to overwhelm because you will typically have a backlog of issues or vulnerabilities that perhaps has grown for many, many years where this testing wasn't being done or was being done periodically. So rather than say, right, we have these 10,000 vulnerabilities that we need to get down to zero straight away, perhaps look at the forward development. And this is the focus now on secure development. Look at the process and perhaps say, okay, from this date in the future, we want to give you the awareness of the changes that are happening. From this date in the future, we want to avoid adding a very, very high critical issue, perhaps where there is a mature exploit or perhaps where there is a fix available. And you do this you add this very, very slowly, and over time increase what a developer needs to do. And this will, over time, build up that developer muscle to say, oh, yes, I understand what is happening here. I know what I need to do to fix it, but I'm not going to do it for 10,000 issues straight away. I'm only going to do it for a smaller number. Now, over time, that threshold can be increased as your development team can consume more of this secure development. And over time, they will become much, much better at being able to do that. And it will become part of the developer process in the same way adding quality tests and fixing quality tests before they push into production had become with DevOps in general. And then once they have grown that security, that security muscle as part of their pipeline development, it's at that point where perhaps we can look at the backlog and say, let's triage some of these and identify how we can reduce that backlog over time. But again, no need to overwhelm and say we're going to do all of these in this first quarter. Let's take the top issues that are the highest risk and add them into various sprints over coming months. And do this with the agreement and working with the developers in that prioritization that the security team can input into.
Thanks so much, Simon. I would like to take just a moment to shout out our other partner for today's event. Thanks so much to Snyk. Named number 39 on 2021's Forbes Cloud 100 list, Snyk is a developer-friendly security platform that helps engineering teams test for vulnerabilities in code, open source dependencies, containers, and IAC configurations. Snyk offers tight integration into various IDEs, source control tooling, and CI/CD pipelines to help drastically reduce mean time to fix. Once vulnerabilities are discovered, Snyk offers actionable remediation advice and helps customers prioritize fixes based on analysis of the vulnerabilities that are called at runtime and bear a higher risk. And if you haven't checked them out, you should definitely go to snyk.com. Okay, so now let's go to the panel where we can ask our questions of Scott and Simon. All right, and now we get into the interactive portion. Please, I love that both Scott and Simon have managed to kind of provide feedback in the chat, but if you do have more questions, please feel free to drop them in chat and I will do my best to ask them. In the meantime, Scott, Simon, thank you both for being here. Let me kick off with Scott. So you talked about your first security hire. Let's take an example. Let's say, so you're a engineering heavy tech startup, maybe SaaS focused, but you're not like hardcore into, fintech or health tech where there are specific regulations. At what point do you hire a CISO and how does that look? Like, who do they report to? Who do they work with? Is this like, are they reporting to the CEO, CTO, CIO? And does the AppSec team report to them or within the engineering org?
Yeah, first of all, Peter, thank you for having me on. Super enjoy workshopping my race team and simile with you. Thanks for having me. It's a super good question, and the answer is it depends. So that first hire in that particular organization is going to be somebody, I think, somebody like a DevSecOps person, right? They're there to help you set up best practices, set up things that will help you do secure development and secure infrastructure and all that stuff without being a blocker. And they're just going to enable you to do the right things very fast. The point where you need a CISO, CISO, whatever you want to call it, is probably right about the time you got to start managing a lot of regulation or compliance frameworks and maybe having security discussions with potential customers. So at some point, someone is going to go, well, how are you securing all this data? And you probably want to have somebody with kind of big picture, high level speaking capabilities to do that. Not that security person in that engineering team can't do that. Those are rare birds, but somewhere around there. And does the AppSec team report to them? If it makes sense. It probably makes more sense to have them dotted line and report to the engineering team. That way their incentives are all aligned and we're just managing risk instead of the incentive being risk management, which doesn't align with delivering software.
That's great. Thanks so much, Scott. So Simon, for anyone not used to like the workflow, like getting down with the weeds and actually getting started with this, I don't want to make it about specific tools, but for something like a Snyk code, right? How and when do you run that? Are you running this locally on your laptop? Do you just hook it into the CI pipeline? Where does this sit?
Yeah, I think it's an interesting one. I don't think there's any, massively prescriptive way of doing something because I think everyone's different. Every organization, every company is different. And I think even within an organization, you'll have many, many teams that act very differently. So you'll have certain teams in your development organization that, are the bleeding edge team, always trying the new things, always trying out new models of development so that the rest of the team, if they show success, can actually start adopting that as well. Then you have this middle group of development teams that will they'll tend to move a little bit slower, typically adopting things once that bleeding edge team have shown it to be very valuable. And then, of course, you'll have this other group of teams that, they don't want to change. They're still doing waterfall. They love the Department of No, that kind of group. So I think when you then try and introduce SAST or any tool really into a development workflow, you need to recognize with each of these teams, where are they currently doing similar testing or getting similar feedback from a build. For some groups, it might be, I don't know, a GitHub action. For others, and I think less mature teams, sometimes maybe in the CI pipeline, or for maybe more modern teams, they're ready in the IDE or something like that. So it massively depends when teams are able to do that. Obviously, the earlier in that pipeline it is integrated, the quicker they get that feedback. So as a developer writing some code, if they can get instant feedback, that's great. But you can't always make sure every developer is testing and adhering to that feedback. So at some point, you need to have some testing to make sure there is some level of policing. And very often, PR checks are a great place to really begin that testing. I would say CI is among some of the most common, just because traditionally it's one of the places that people would see a lot of testing in. But yeah, it massively varies.
Hey,
That's
Peter,
yeah.
Real quick, I totally agree with what Simon's saying here, but I always think of it like this: if you're running some tests in the CI pipeline and they can fail and stop your build, you should be able to run those tests locally. So the most advanced teams may just go, everything happens in CI. If they can't recreate why those things failed in CI locally, you're going to have a bad time. That turns into, cool, now I'm going to work around undoing how this actually is breaking my build. So kind of my best case scenario is, if you're building some kind of testing into a CI pipeline, make sure you can also do that in some form or fashion locally, so people can recreate and fix.
And that kind of thing, years ago, before we used to consider it great practice for devs to write unit tests and integration tests, etc. In those days, we used to just push that code through, and another team used to test. But then all of a sudden, we said, okay, let's start adding integration tests, which then became a regression suite that ran as part of a CI pipeline or an integration test. And those, if we didn't run those tests locally before we pushed it into a build, we could start failing builds, and you'd be that person, that developer, right? Security testing is no different. Mm-hmm. It's just a form of a quality test, whether it's trying to be bug free from a functional point of view, availability, a performance, or a security. It's similar kind of way of looking at that.
That's great, Scott and Simon. Thank you. Scott, you talked about static versus dynamic, right? SAST versus DAST. So what kind of issues can you capture with SAST? And is it in part a function of the language, like whether it's statically typed? And then how and when can you just say, oh, I've got DAST, so I don't need SAST, or do they really play best together?
I think Simon can probably give us some more insight into the static code analysis and what you can and can't find there. Because I know some of it, but he's obviously probably more of an expert there than I am. But I think to me, and I put this in the chat, what works for a dev team and they use is probably the best tool. Like, if you're going, okay, we need to start our AppSec journey, get 3 of those things in there, SCA, SAST, and DAST, and like demo them. By the way, if you're a security person and you're trying to find an AppSec tooling and program to help you build out the stuff, and you don't have a dev team, you did it wrong. Go get some dev team members and have them come with you. Whichever one they use is the most powerful one, right? A tool you use is very powerful. I like DAST because it actually does a really good job of going, the thing that we found is discoverable and exploitable in the running application. And that's typically how you do that. SAST does a really good job of going, you wrote this in a weird way or a wrong way, or you probably didn't handle it. It sometimes has a problem going, and it's exploitable. Sometimes you can get pairs of these tools that work really well together and tell you both things at the same time. And that is like the holy grail of like, how do I prioritize my time in application security? But that's kind of how I think about that today.
That's great. Thanks, Scott. Simon, so when you think about software supply chain or SCA, right, how and when do you actually test those dependencies? Again, trying to understand whether this is like something I run locally, CI as part of the continuous deployment build. How and when should that actually be run?
Yeah, so this is an interesting one because with SCA, for example, we are looking. The big difference there is whether a vulnerability is known or unknown. If it's known, it exists in a database, and that database is kind of like compared with the dependency graph that you have built. So the big difference between that and say something whereby you're looking at whether it's SAST or DAST is the code is already there, the vulnerability is there. It's known when the tool tells you about it, and the tool will tell you about it today as it will tomorrow, as it will the week after. The difference between SCA is when it gets disclosed. So depending on when that gets disclosed, you will obviously find it or not find it, depending if you're introducing that in a pipeline, or if you take something like Log4j is a great example, or I don't know if this Spring RC is going to be called Spring for Shell or Spring for Shell. The difference there is obviously when you look at these 0 days, doesn't matter what testing you do, at the time of going through that pipeline, it wasn't known about, and as a result, wasn't in the database. So that's always going to turn green. But as soon as there's a 0 day, it's about scanning to identify what you've already got in your production, what you've already monitoring, to be able to give you this instant notification to say that thing that you were monitoring that wasn't vulnerable, or we didn't think was vulnerable before, we've just noticed there's a new vulnerability that now affects it. So I think when you look at a pipeline, they're going to try and allow you to make good decisions as you're making changes to your code. But you also need to then look at it from what have we already got, and when a new vulnerability comes in, what can we do about it there? The third space, and I think this is becoming more and more interesting when we think about supply chain, is really about the risk that we are adding when we pull in new libraries. What is going to stop us from getting another known vulnerability in a week or 2 weeks? And it's interesting when we look at things like Log4j or Spring, any kind of like Spring component, because these are very, very well known, very well used libraries. Okay, it doesn't matter how you do these, you look at these libraries and say, is it popular, is it well maintained, etc. They're going to come up in some good light, but all libraries are going to have these types of vulnerabilities in them at some point. It's just a case of when. But one question that we should ask early is what is the risk? What is the health of these libraries that we're adding in? And there are a few things that we can test there. Things like health with maintenance. How often are they being contributed to, released? How many commits? What are the number of open pull requests, number of open issues, those kind of things? How active is it? The community, how big is it? How many contributors are there? The number of issues, whether the issues, security vulnerabilities, indirect as well as transitive, how long they last, all these kind of things are really great metrics of whether a library is, should be trusted or not trusted, whether you can rely or depend on that. So that's definitely something which can be done early. But yeah, when you're looking at whether you should be using a library today and trying to scan whether it's got vulnerabilities in from an SCA point of view, you should be doing that throughout your pipeline. You can do that in the IDE. You can do that in the when you create a new pull request to test whether you're introducing new vulnerabilities. CI, again, obviously it's being, everything's being built there, so you're a touch more accurate to what you're going to be deploying there, depending on environmental changes. So you can scan at all these points just to double check. And exactly what Scott was saying earlier, right? If you're testing early, you shouldn't see surprises and you shouldn't see builds failing, because you've already done those tests and you've already taken that feedback aboard and made the changes that you needed to early.
That's great, Simon. Thank you. Scott, so you said it's not the job of the dev team to be security experts, right? But there is some minimum subset of knowledge, like, SQL injection is bad. We should probably sanitize our input from users. What is that minimum subset of knowledge they should have, and how do they go about getting that?
For the most part, they know about most of the large issues already. They just call them something different. So this is if we're looking at some security vendors here on our call, you can blame us for some of this, right? SQL injection, cross-site scripting. Let's see, command OS injection. That's all unsanitized user input. Direct object access in API security is called tenancy filtering. Like, the words exist and people know about most of them. We just have done a really good job of being very specific and confusing for everybody. So the thing that I think is really important there is not so much that you know the details of all these things. It's that you're kind of aware of what's happening, and the ability to make a vulnerability or an exploit, like to replay it. And that's one of the cool things about DAST is you can see the exploit and replay it and understand what's happening there. And then, you know, if you've got SAST and they're correlating findings, you can go, oh, it's in this piece of code, so I'm going to set my debug points here, replay the attack and watch it flow through the code and go, oh, I see what happened, right? Those things are really what help developers and engineers go from, I see this problem, to I understand what this problem actually is very, very quickly. And that's really important because you don't necessarily want to make people dig around on the internet or wherever to try to understand an issue quickly. And that's I always think about it as like, you've got a small attention span. Developers are curious by nature. You've got a small window to like grab them and go, here's what it is. And then they go, oh, okay, cool. If you make that too hard, if the tooling or the process or whatever it is, well, all of this is culture, right? Tooling supports culture. If you make that process too hard, you know, that's where it turns into, I don't care. They do care. You just lost their attention span. They've got stuff to do. If you can grab them in that attention span and go, here's what it is, and get them engaged, they're probably going to just fix stuff, which is actually crazy. Like, if you talk to a dev and you go, if I told you about a vulnerability and you understood it quickly, what would you do with it? They don't go not care about it and push bugs into production. They go, oh, I probably fix that, which is awesome. That's what we want them to do. So that window of like opportunity is really, really important.
That's great. Thank you.
And just to, I mean, I agree with everything Scott just said. And I think there's a big distinction between security and secure development. And it's perfectly acceptable for a developer to understand secure development and secure development activities. But there's no depth in security they need to go into to understand that. That's where, you know, that interaction, the kind of like people connection with the security team and the security experts kind of jumps in when they have, when there's an anomaly there and they're like, oh, actually, let me understand what the actual risk is here, because this is actually a tricky one to fix. Let's understand it in more depth. That's when you get that interaction with, you know, with the sec team and the dev team in depth and say, okay, let's work on this together and really understand it, because that's what, you know, to get a truly autonomous development team, they need to be able to have everything they need to fix themselves. And so, yeah, I totally agree with what Scott was saying.
That's great. Thank you both. So Simon, how much DevOps sophistication do you need to actually add some kind of DevSecOps tooling into the CI pipeline? Like, is this like, you know, master ninja level, or is this something that as long as you can get the other tests running, it's just another suite of tests?
Well, it's a good question. I mean, and kind of like it's interesting when you say DevSecOps and DevOps as if they're almost two different things, when actually are they different things, or is security just another aspect of DevOps? And I think, you know, the flows and the model that DevOps kind of like provides us with, it gives us that platform where you can plug in as much of you know, as you want. Whether it's security or other things, it's about breaking silos down. And just because for some reason we stopped with operations and things like that, doesn't mean we shouldn't have put security into it. So, you know, the big thing isn't necessarily about how security fits into that DevOps pipeline, because it should fit in the same way as operations and everything else fits into that DevOps pipeline. The big difference is, in years gone by, we as an industry have traditionally built tools that were fit for security auditors and not for developers. And so the shift needs to go not in the sense of how can we fit this security thing into DevOps. It's a case of how can we reimagine what we are doing right now to provide developer tools that gives them that information to be, developed securely. And so, yeah, we don't want security to be anywhere outside of that DevOps pipeline. It 100% needs to be in that pipeline and fully integrated. So yeah, great question, but really try and consider security as DevOps. There's no magic sauce that DevSecOps provides on top of DevOps. It's DevOps, but at the time, security didn't get the memo, so we had to create another buzzword. and great question, Scott, with the ATAT. I've had this ATAT for probably about 40 years. This is one of the originals from the original. These are plastic. In the other room, just over there, I spent an extortionate amount of money on the Lego version, which I'm about 7 or 8 packs in. So yeah, that's me and my wife are working on that one right now.
Very cool, Simon. Thanks so much. Scott, how do you think, so I've kind of like been assuming a lot of this is like application, you got a website, web application, a SaaS product. How do you think about API testing, especially now, more and more people, you've got kind of the back end and then you've got a React front end that engages with that. Is it substantially different?
I was on mute, sorry. I think it is different. I think it is different insofar as how you think about it. But generally, it's not different insofar as an API is a web application. So that's the baseline. Right? All web applications are the same. The API is actually a little bit different. And I think a lot of people struggle with this abstraction of like, what does this mean? So a lot of security people think of the front end and the API as an application that goes together, and they can't be decoupled, which is not true, right? Bad actors, threat actors don't have to use your front end to talk to your API at all. They can, but they don't have to at all. So the thing that I like about API testing and how to think about it in a different way is to decouple those things, because different teams work on them in the first place. So when you start talking about, we're just talking about DevOps and DevSecOps and all this stuff. If you go, this is all one application, I'm going to test it all at the same time, and then all the findings that come out of it, now I got to go hunt around the organization. Where did they go? That's not very DevOpsy, and not very self-serve, and not very serving to those DevOps teams. If I can test the front end team, there's probably a front end team that's working on the front end, or even sections of the front end. And I can test the API or the microservices behind an API gateway or something like that, and be able to feed those teams information about their service that they're building quickly and easily. I have much more disambiguated, it's a big word, information that I can then parse out to the engineering teams who are responsible for this. And I don't have to participate in all this Jira ticket kicking that happens in like legacy security models where you're like, oh, you guys own this. No, we don't. Not anymore. We organize shift and it's actually this team now. And they go, we don't know anything about this thing. We just got it last week. If you can feed that information to those teams while they're building, before they're deploying, you get much better engagement rate, much better fix rate. Again, that's what we want people to do, right? The whole point of this is fix things, not make pretty PDFs of our problem. And getting that information to those teams quickly, in context, and making them small. So like this stuff that I just got served in my CI pipeline relates to me. Super important. And because of the proliferation of APIs, I think it's actually gotten easier to do that, which is crazy. Microservices and APIs. But we haven't brain shifted enough to think that way quite yet.
And a good follow-up question, Scott, can you spell disambiguated?
Nope. Simon, I can barely read.
Unfortunately, we are almost out of time, but I do want to slide. Thank you so much. Got one final question for Simon, which is, so infrastructure as code, right? That's kind of another kind of DevOps best practice. How do you think about security for that code?
Yeah, infrastructure as code. I mean, where we talk about multiple different areas of the security of our applications, we really need to try and work out what are the where is the kind of like the weakest point of our application. And there are, while your DAS and your SAST is great for your codes, SCA great for third party, we equally need to think that the container, the infrastructure as code, that's all becoming part of the application these days. It's all hitting GitHub, and as a result, it needs that AppSec methodology, that AppSec workflow of being able to test that. And you look at IAM roles being misconfigured, S3 buckets being left open, and things like that. These very often aren't because there's someone's written, do I want my security of my S3 bucket open or closed, and they've hit open rather than closed. These are misconfigurations through insecure defaults and a whole bunch of things like that. And these kind of things, without us templating a lot of IAC files that people can reuse, it's very easy for developers to unwittingly add these kind of issues and misconfigurations in. It's extremely important area, and I think with more and more developers and thinking, thousands of developers rather than a few ops people trying to work on this, we need to work out how we can scale that. And the way to do that really is to do testing again through the pipeline of IAC changes and IAC configuration. But yeah, very, very important area that's growing in concern for different groups as well as importance.
Unfortunately, we're just over time, but Scott, Simon, thank you so much for hanging out and sharing all your wisdom. This was great.
Thanks,
Appreciate
Peter.
it.
Thanks,
Thank
Simon.
you.
Thanks again to our speakers, Scott and Simon, to our partners for this event, Snyk and StackHawk, and thanks for you for taking the time to join us here today. Until next time, thank you. Bye.